This lesson is on identifying one-to-one functions. So we've spoken previously about functions and how to tell if a relation or a set of ordered pairs is a function. Here we're going to talk about relations that we already know are functions and asking, are they one-to-one? So what one-to-one tells us is that each y value must have a unique x value. So whatever is in my range, it should map back to only one value in the domain. So here's another way to write this. So if a does not equal b, then f of a does not equal f of b. Or we could say if f of a equals f of b, which means if two y values are equal to each other, then that means that those x values must also have been equal in order for it to be one-to-one. So let's look at these two relations. The first one is a function because I have unique x values that don't map to the same y value. So when we check for a function, we're saying, does every y or every x have a unique y? Now we're looking at not whether or not it's one-to-one. So here, notice all of my y values, 7, 2, 6, and 4, these are all different. But if I look at my other relation, it still is a function because each x value has only one y value. However, 3 maps to 7 and 9 maps to 7. So therefore this is not one-to-one because 7 maps back to both 9 and to 3, and so they're not unique x values. It's a little bit easier to tell when you're looking at a mapping like this. So when I'm looking at a mapping, I'm saying, is there essentially a y value? So this obviously is my domain and this is my range. And when I'm checking, I'm saying, is there a y value that has more than one x value? And so of course in this case 1 maps back to both 5 and to 9, which means this is not one-to-one. Not one-to-one. Now if every y had only one x mapped to it, for instance if I took this one away, now all of a sudden that is one-to-one. Previously we used something called the vertical line test to determine whether or not a relation was a function. And how that worked is we would just draw vertical lines, which are straight up and down, and any time that that line would hit more than one point on our graph, we knew that it wasn't a function. So similar to that, we actually have something called the horizontal line test, and the horizontal line test will tell us whether or not a function is one-to-one. So if I were to draw any kind of horizontal lines, and if I only hit one point every time I draw a line, that means it is one-to-one. Each y has only one x. So this is one-to-one. This function, however, as you can see, if I draw that horizontal line, I now have 2 points. And I have 2 points. And here I have 1, 2, 3, 4 points. So this is clearly not one-to-one. So one way to do it is the horizontal line test. You can use a mapping, or you can just analyze the points in the relation. If you actually have a function where you're trying to determine if the function is one-to-one, what we'll do is we'll essentially show that if f of a equals f of b, then a must equal b. So what that means is I'm going to plug in, if I were to find f of a, that would of course be 4a squared minus 7, and f of b would be 4b squared minus 7. So what I'm going to do is I'm going to set those equal to each other. So 4a squared minus 7 equals b squared minus 7. And now I'm going to simplify these. So I'm going to add 7 to each side, which gives me 4a squared equals 4b squared. I'm going to divide each side by 4, which gives me a squared equals b squared. And then I'm going to take the square root of each side, and that gives me a equals plus or minus b. So this is not, I did not end up with a equals b exactly, and therefore this is not one-to-one. Again, we should already know that because if we look at this, this is obviously a quadratic, and if we graph a quadratic, the general shape is a parabola, and so it would make sense that it would not be one-to-one. Here are 3 different questions for you to try. So press pause, try all 3 questions, determine whether or not they're one-to-one, and then press play to check your work. So for the first, I've got 2 mapping to 7, 3 mapping to 9, and 4 mapping to 8. Those are all different, and so yes, that is 1-to-1. Every y has a unique x value. For my second, I'm going to say 2a minus 7 equals 2b minus 7. And then I'm going to add 7 to each side. And then I'm going to divide by 2 on each side. And because I did end up with a equals b, then yes, this is also 1-to-1. And my last one, I think, is pretty clear that this is clearly not 1-to-1 because it hits several points if I use the horizontal line test.